Okay, my people, we are back. Let's go over some more details of um, some general details of all three tests, all three chi-squared tests and their distributions. Okay, so where do we start? Well, chi is a Greek variable right there. It looks like that fancy looking x. We don't call it x squared, we call it chi-squared. So don't get into bad habits there. Okay, all three tests are going to have this thing called a test statistic. And that is what we call the chi-squared statistic, statistic right there. And this is the formula which we'll go over more in detail. If you can see by the shape in here, all of them are what we call right skewed. And there's a reason for that. As you develop more experience, you'll realize, oh, now it makes sense why they're all right skewed in here. And notice the shape of each one is constantly changing based upon the degrees of freedom. We'll go over how we calculate degrees of freedom later on. It's going to be based upon the number of choices in your categorical variable. But keep in mind the peak and where the peak is located and the shape of that particular distribution is constantly changing based upon the number of degrees of freedom. Okay, what else is different? Well, we have all the hypotheses, because remember, these are not significance tests, but they kind of feel like significance tests where we're going to have p-values, we're going to have an alpha level still, significance level. But the hypotheses are always going to be stated in words. So that's a big difference between significance tests from prior chapters and moving forward. It does say here, no one-sided test, but let's clarify. They are going to be one-sided, and they're always going to be one-sided to the right. There's going to be no such thing as a left-sided test, only right-sided test. There's no such thing as a two-sided test here, only to the right. And if you see in this diagram, notice where our p-value is. Notice it's to the right of some chi-squared statistic right there. So this is color-coded here, and that leads me to my next point, the subtle difference between a critical chi-squared and just a chi-squared statistic. So if I say chi-squared or chi-squared statistic, I am talking about the same thing. But we are not talking about the same thing when we say critical chi-squared. Now, we won't use the critical chi-squared with a four-step process, but we are going to be able to calculate that once we get some more experience. And that's going to be connected to the alpha level right there. It's essentially the line in the sand, which is going to produce the probability of us rejecting the null. So in most cases, the significance level is 5%. So it's basically this critical value is the line in the sand where we're going to get a 5% outcome. The p-value, on the other hand, is not necessarily 5%. It could be 15%, it could be 13%, it could be 2%, it could be 1%, it could be very, very small. So the chi-squared statistic is basically what we need to calculate in order to get our p-value. And ultimately, we're going to have a fight between the p-value and the alpha level to determine whether or not we're going to fail to reject the null or to reject the null, just like other chapters. All right, so how do we calculate a chi-squared statistic? So this is going to be your first introduction to this formula and the vocabulary we need to use. This could be very blurry for students. Now, again, we are only focusing on the chi-squared statistic, which is just called chi-squared. And it's really the sum of a lot of numbers put together. What are those numbers? Well, you're going to be taking your observed count, not your proportion, your observed counts, minus what we call the expected count. I cannot stress enough, these are counts. You're going to be subtracting those, squaring it. Notice you'll get a positive number, and then divide it by your expected counts. And then you're going to do that for each of the different outcomes of your categorical variable, add all those up, and that's going to produce your chi-squared statistic. This does get reported in the four-step process, and this is what's going to determine where so it's going to determine this probability, which is our p-value right there. Okay, so finally, before we get moving here, focusing just on the goodness of fit test, I highly recommend you go to our inference link game that we've played before. Click on that link and check all three of these boxes to start to stumble. You're going to start to see that all three of these are going to be very blurry at first. And no one is ever good at this at first. Meaning, can I distinguish the difference between a chi-square goodness of fit test, a chi-square test for independence, a chi-square test for homogeneity? And just by reading those differences and stumbling, that should just give you some initial awareness of, whoo, these can be quite blurry. And the homogeneity one is blurry compared to a two-sample z-test that we did in chapter 10. So get some experience with that, and the next video is going to start with the details of a goodness of fit test.